So if you have your basic quadratic equation here, and all three of the squared terms are present, then there's one of two cases. It's either going to be an ellipsoid or an hyperboloid. So again, if you have all of these square terms, then the linear parts can be absorbed by completing the square. So we're really talking about a situation that looks like this. We've got ax squared plus by squared plus cz squared equals j. And if you think about it, either all three of them have the same sign when they're together on this side, or there could be one that is different, right? So maybe a and b are both negative and c is positive, or b and c are positive and a is negative. There can either be all the same, or there can be one odd one, so one that's different from the others. So let's think about the case where they're all the same, they're all positive. Here, this might be an example. Let's say a, b, and c are all positive. So x squared, they're all 1 actually. X squared plus y squared plus z squared equals 1. Now you recognize that that's a sphere already, but think about what happens if you look at traces. If you set x equal to 0, you have y squared plus z squared equals 1. That's a circle of radius 1, so in the yz plane. So this is y, that's z. We're going to see a circle of radius 1 in that yz plane. So there's a circle of radius 1 that way. And if y equals 0, then the trace in the xz plane, we have x squared plus z squared equals 1, so that trace is also a circle of radius 1. This time it's in the xz plane. And let's see, if we look at traces when z equals 0, then if we set z equals 0, we have x squared plus y squared equals 1. So the trace in the xy plane is also a circle. So no matter how we slice it, we're seeing these circles in all these directions. So this is a sphere then, which is the special case of an ellipsoid. An ellipsoid, when we slice it, no matter which direction we slice it in, if we see ellipses, then it's mostly ellipses. In fact, it's all ellipses. We'd call it an ellipsoid. So here's an example of something that's an ellipsoid that's not a sphere. So again, though, if you look at the traces, if you set x equal to 0, then you have this ellipse, y squared over 4 plus z squared equals 1. So it's not quite a circle, it's an ellipse. It goes out 2 in the y direction, but only 1 in the z direction. So we can go back 2 and down 1, so we get an ellipse like this. A little bit hard to see because this is in the yz plane. The yz plane, so we're looking at it there. If we set y equal to 0, the trace is x squared over 9 plus z squared equals 1. So we have an ellipse in the xz plane. It can come out 3 in the x direction, but only up 1 in the z direction. So go back 3 in the x direction as well. So we see an ellipse like that. Okay. And if we look at z equals 0, then we're in the xy plane. So we have x squared over 9 plus y squared over 4 equals 1. That's an ellipse in the xy plane. No matter how we slice it, we see ellipses. If you can kind of visualize the wireframe that's emerging here, you can see it's like a sphere that's been kind of smashed. So depending on how it's smashed, it might look like a football. This one's a little bit wider in the y direction than it is in the z direction. So this is like a football that somebody's stepping on because it's even longer in the x direction. But it's basically a smashed ball of some sort. That's an ellipsoid.